Did you ever notice in front of your house there's power lines? That's right. They're smaller power lines, but did you also notice that sometimes as you're traveling across the province that you see these very, very large power lines? So the reason is that sometimes in order to transfer electricity from one end of the province to the other, we have to use bigger power lines to get them from one end of the province to the other. But what we do with electricity is we use the voltage. So we change the voltage of the electricity so that we can send it further away, for long distance away. So that's why electricity can be very dangerous. We've talked about that. So we have a model here to show you a little bit about the hazards with electricity and where you might find them. When we have very, very high voltage electricity, the electricity, you don't even have to touch the electricity because the voltage is so high, it can actually jump in the air and it can reach you. Have you ever seen substations such as this one? So there are some in your neighborhood, different locations where we have power substations. And what we have in those substations in many cases is we have what's called transformers. So the transformers change the electricity from one voltage to another voltage. So the voltage of the electricity down your street is probably a relatively low voltage, such as maybe 25,000 volts. So it's still high voltage, but it's 25,000 volts. But in these substations like this that have a big fence all around and there's signs, danger, don't enter. So in those substations, there's a power transformer that might change the electricity to a very, very high voltage, possibly up to 345,000 volts. Wow, that's a high voltage, isn't it? So at that voltage, the electricity is even more dangerous because you have to stay even further away because the electricity can jump in the air. So is there any good soccer players here in the classroom? Who's a good soccer player? Yes. I know you're a good soccer player. We heard about you all across the province. Everybody says that is the best soccer player around the province. I do not agree. I don't think you're a very good soccer player. If you're such a good soccer player, why did you kick your soccer ball into our substation like this? What we at Nova Scotia Power want, we really don't want you to climb the fence or try to get under the fence to go get your soccer ball. You are forgiven. Please, instead, call Nova Scotia Power. We'll go in the substation. We'll get the soccer ball for you because the voltages in such a substations are so high that what happens is if you go in there, you don't even have to touch a wire. You just have to get close to a wire. And what happens is the electricity can jump in the air. And it is so dangerous. So please don't go inside substations. So is there anybody who likes flying kites in the classroom here? It's a lot of fun flying kites, isn't it? Yes? You've flown a kite before? Are you a good kite flyer? It's difficult though, isn't it? Very, very difficult to fly a kite, right? You're flying the kite and then all of a sudden the wind takes it and it goes left, and then the wind takes it and it goes right. So it's very, very difficult, and then it falls on the ground. So that's why we say when you're flying a kite, make sure before you fly it, before you put it up in the air, always look around. Make sure there are no power lines, because if the kite gets caught in the power line, the electricity can come down to ground like this. Oh! And who's on the ground? It's you that's holding the rope of the kite. So the electricity is going to come down through you. And you know the damage that can do. Let's look a little further in our model. And what do we see? Oh, there, look at the nice, cute little bird on the power. Hold it. How come we have a bird on the power line and he didn't get hurt? Can anybody answer why we have a bird on the power line and he didn't get hurt? That's right, because electricity always wants to go down to ground, but the bird He's not touching the ground, is he? He's just sitting on the power line. So the bird is essentially becoming electrified at the same voltage as the power line. So the bird, when it's flying through the air, just a normal bird, then he lands on the power line, and if he doesn't touch anything else and only the power line, the bird is okay. He just becomes electrified at 25,000 volts, but he doesn't touch anything else, so he's okay. And then when he flies away, the electricity dissipates and leaves him, so the bird doesn't get hurt. So let's talk about driving a car. Why am I talking about driving a car? When the weather's great outside, the roads are nice and dry in Nova Scotia. We have beautiful, smooth, very nice roads in Nova Scotia. You're driving, your teacher's driving the car, everything's going great. But we also have winters in Nova Scotia, don't we? And in the winters especially, the roads get snow-covered, the roads get icy. And then what happens is we do have car accidents. And oh no, your teacher has hidden the power pole. And you like your teacher, you want to help your teacher. So what's the first instinct is you're going to run to the car to say, can we help you? Well, this unfortunately is the wrong instinct. You have to look first, because if the car hits the power pole, there's a chance that the wires could come down. Can you see the wire? It fell down on the car. But the car has rubber tires, doesn't it? And rubber is a good insulator, isn't it? Yes. So the problem now is we don't know if there's electricity in that wire, because you can't see electricity, can you? We don't know what electricity looks like. There's a wire. There might be electricity in the wire, but we don't know. We can't hear it, we can't smell it, and we can't see it. So if you decide that I'm going to take a chance and I'm going to touch the car and I'm going to help my teacher, then this could be the worst thing you do, because you are touching the ground, and as soon as you touch the car, the electricity is going to go down through ground through you. So the best thing for you to do, stay away. Make sure there's somebody that calls 911. There's been a car accident. Someone call 911. Call for help. Tell people to stay away. You've told your teacher to stay in the car. You've tell everybody to stay away. We've called 911 so that they have called Nova Scotia Power. They've called the police. Everybody's responding. But sometimes, though, with a car accident, there might be a fire because there's gasoline in the car, and there might be a little bit of arcing with the electricity in the wire and the car. So the teacher starts to smell smoke and see fire and say, uh-oh, I have to leave the vehicle. How do I get out of the vehicle? Well, let's show you how you get out of the vehicle. Okay, so the first thing you do is you would take your seatbelt off, obviously. Take your seatbelt off. Now open the door as wide as you can. And now try to stay as confined as you can. And turn yourself ready to leave the car, but do not touch the ground, and try to touch as little about the vehicle as you can. And now in one giant step, you're going to hop out of the vehicle so that you can land on your 2 feet, so that you never touch the vehicle and the ground at the same time, just like this. And now, once you land on the ground, then you're still not safe, because remember, your vehicle, that car, could be energized at 25,000 volts, and you're standing on the ground just maybe a couple of feet away. So what you want to do then is you take very, very little step, because if you were to take a giant step, you could still have too much voltage between your feet. So you take a very, very little step like this, shuffle, 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 until you're quite far away from the vehicle, and then you're safe. So, did you ever notice in front of your school maybe, or maybe in maybe the big malls, shopping malls, etc., or office buildings, that sometimes there's a big green box on the ground, and you probably have one near your school, don't you? Yes, something that resembles something like this. Yeah, so those is also a power transformer, the same as the very large power transformer that's in the substation. But the difference is that power transformer converts the electricity, the voltage, from maybe the 25 kV, 25,000 volts that comes from the distribution line, and it converts it into a lower voltage, such as probably 600 volts in this case, probably, that goes into your school that can then power all of the equipment in your school. You've probably noticed that on these power transformers, we have these danger, high voltage, don't enter, etc., because the electricity in those power transformers is very high. So we inspect them every year, and we put a padlock on it, and we lock them, make sure the doors are closed. So it's okay if you go to it and you touch it, but we don't want people to jump on them and play around them and play on them, etc. And even worse, if ever the padlock was open or the door was open, the electricity inside that pad mount can be very, very dangerous. So that's why we don't want you to go near a pad mount transformer like this, because the electricity can be very, very high. Okay, so we want to stay away. Okay? So cats like to climb, don't they? Huh? They love playing around, and cats can really climb. Sometimes cat can climb power poles. They got these these big claws, and they can climb up the pole. So what we would want is we would never, ever, ever want somebody to put a ladder to try to go and rescue a cat on a power pole. Because again, most of the ladders are made of what? Aluminum, probably, because aluminum is light and aluminum is strong. So therefore, a lot of our ladders are made of aluminum, but aluminum conducts electricity very well. So now if you put a ladder on a power pole, chances are the ladder is going to move a little bit. And when the ladder moves a little bit, it could contact something that carries electricity up on that power pole. So what we would rather you do is, the cat's most likely going to come down on its own. It's going to get hungry, and when it gets hungry, it's going to come down. But it's not going to come down if you run to the base of the pole and you say, Carrie, 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 come on down, Carrie, Carrie, come on down. No, Carrie thinks she did something wrong. Why are they yelling at me? What did I do wrong? And Carrie's going to be scared, and she's going to stay up there in the pole. So what we would rather you do is get Carrie's favorite treat or favorite food, put it in a dish, put it at the base of the pole, and then leave. Now Carrie's going to get hungry, and Carrie's going to come down on her own because she's going to want to eat. So that's the best way to get the cat off the pole. Now, if Carrie is still too scared and stays there for much longer, and you worry, you can always call Nova Scotia Power. But at Nova Scotia Power, our power line technicians, they have these rubber gloves that they can work near power lines. Nice thick rubber. But this thick rubber doesn't like Carrie's claws. If Carrie's claws got Carrie to climb up that pole, it's going to make a hole in the rubber glove. So the power line technicians will have to be very, very careful and can't use the rubber glove to get Carrie away, because now the power line technician can get hurt. So the power line technician may have to use one of those sticks that they have. They're called hotline tools, to coax Carrie to come down the pole. So it's much better to put food at the base of the pole and try to get Carrie to come down on her own if she can. The best way to get Carrie home safe, right?